again. So next presentation about running large language models locally. And this is me. This is a little bit about making models smaller by going from 32 bits to 16 to 8 and eventually to 4 bits. But it's not just truncating or rounding. You have to actually follow a certain procedure to decrease the size of the numbers while not decrease the accuracy. So this is called, this compression is done using GPTQ, gradient preserving quantization, a neural network-based quantization algorithm that minimizes the loss in accuracy caused by quantization. Okay, these are, like I put in one place, requirements, what kind of computer you need to run different models. Like all the models listed here are llama-based and different size, 7 billion parameters, 13, 30, and 65. So this is approximately the weight of the model. This is what RAM memory, system memory you would need. And this is video memory you would need. Examples of video cards which would deliver this kind of memory. And some statistics about speed. I haven't finished the table, but that's okay. So if you concentrate on 7 billion and 13 billion parameters, which are small models, you can run them on maybe 6, 10 gigabytes of video RAM. So you can use something like NVIDIA RTX 3060, which is several-year-old computer, not expensive. It's maybe your laptop. And of course, you can use 3080, 3090, and others. So it's not difficult. But if you want to run bigger models, you need more video memory. You need maybe 24 gigabyte 3090 or more expensive, or for bigger model like 70, 65, 70 billion parameters, you maybe need 2 of 3090s. Each 3090, if you go today on eBay, well, you may buy used at about $700, and new would be $1,000, maybe $1,300. So this plus memory, system memory, like a rule of thumb, should be about twice bigger than the video memory. CPU is not really important, like some decent modern CPU will do. And that's it. So the desktop to run 13B model can be built for under 3K, actually for under 2K. Okay, this is Ollama. So what is Ollama? Ollama, it is an open source project, so you can go on GitHub, and this is it. So you can download for Mac OS, for Windows and Linux coming soon. I mean, they have it, but it doesn't have GPU support yet. They're working on it. But you can build it from source and run it. So when you install it, what you will get is, this is my terminal. Let me make it bigger so you can see what I'm doing. Which Ollama, and it put Ollama executable here so I can run it. Ollama list. So it shows the models which I downloaded on my computer. These models are sitting in the directory called .ollama. And here I have logs, I have models, whatever, it's sitting here. Let me run Ollama run. Okay, I used this model last time. And let me see what was the last question. Okay, why the sky is blue? And this is 13 billion parameters, so it is a little bit slow because I'm running it on my laptop, which is not a supercomputer. Okay, so it talks about relay scattering, reaches at whatever. So it actually has some knowledge about physics and so on. Okay, let me stop that. So it kind of works like ChatGPT, but what's amazing that this is local and it's very, very easy to use. So if I go to ollama.ai, and this is the website where you can download for your Mac. Again, if you want for Windows or Linux, you'll have to go to GitHub and download the source code and build it. This is the list of models. You see they already prepackaged many models. So you can go here, okay, stable beluga, and this is whatever. Let me take something simple, Llama 2. They changed the interface. They used just to have the list and okay, this is how you download it. You just run this command on your prompt and it will download, and then you can run it and play with it. Okay, and so let me go here. So this is a simple way to run the models without any code whatsoever. You don't need Python, even simple Python. You just download and run them as is. Also, it creates like a local website endpoint where you can send your requests and it will reply with JSON. So yeah, you can do this. Okay, this is the list of models. This is from several days ago. I think today I've seen more models already. So this is example how you need, how you can run a model which is Llama 2, 7 billion parameters on local computer with the GPU. So this is the article, and these are the steps, and this is a very small print, but you see it's not much. So these are mostly configurations of your model, and then here on the bottom it says generate text, and then the question, explain to me the difference between nuclear fusion and fission, or fission and fusion. And then it's print, and it will print the result. So this is really how easy it is to start running models locally. How to run Llama 13B with 6 gigabytes graphic cards. So this example using a project called Llama CPP, and this is open source. It's on GitHub. So this is the link, and this is all the operations you need to make it happen to run Llama 13B on your computer. Okay, pre-processing documents to improve vector search. Oh, this is a interesting subject. We're thinking about creating about the project where we would use local large language model and local embedding model and local vector database all together to make a system to do search inside documents. Let's say you have millions of documents and you want to search inside them using natural language interface. That means using large language model. And for that, first what you do, you take your documents and you split it in chunks. You convert chunks into vectors and put them in the database. But these chunks may have completely different format. And then when you try to search, what you're doing, you're using similarity search, like cosine similarity of vectors generated from text. If original pieces of text had completely different format, you will not really be comparing apples to apples, right? So one of the ideas is, let's say your documents are resumes, right? And you want to find good candidates using certain search criteria. What you can do, you can convert your query into format and your resumes into the same format, which looks something like this, which is structured. And then you convert these structured pieces of text into vectors. And then when you compare query to your vectors, you'll be comparing apples to apples, and you will get more relevant results to your search. Another approach which some people use, they convert documents into question and answer pairs. There are a lot of tools, like here, for example, let me click on this one. This is a GitHub. You see it has 775 stars, so it's a good project. And you can easily take your text and convert, split it into question, answer. And then you can put these questions and answers in the database. And then when you have your question, you can search among other questions. Again, you will get better search as a result. Okay, next. Understanding fundamental limitations of vector-based retrieval for building LLM-powered chatbots. Well, I just touched on that. The idea is that when you just take the pieces of text and just convert them to vectors, maybe it's not the best way to do data search, data retrieval system. In fact, it's for sure not the best. There are other better ways. You can train custom models. There are a couple links here. And another thing about using embeddings that they're actually expensive. So here there are estimates for PubMed, where we have 35 million abstracts, which we split each abstract in about 3 chunks. So we have 100 million chunks. Then we using Pinecode VectorDB, which is a very good VectorDB, but it is closed source. It's commercial. They charge, and you estimate like 7,000 per month. Then if you one time you want to generate vectors for all these abstracts, you will pay something like $125,000. Then you will have to pay for storage. Then if you have 100 million queries per month, this will require $250,000 per month for creating embeddings from these queries and getting responses from OpenAI. So the whole project becomes very expensive. And also it takes a lot of space. For example, when you're creating embeddings, even not very big embeddings, still the amount of space they'll be taking will be at least maybe 3, 4, maybe even 20 times more than the original text. So which requires a lot of storage, which requires a lot of compute power and high costs. So alternative to this approach may be not to use embeddings, but instead use simple key value pairs. Basically make a hash with millions of buckets and use a custom neural network as a classifier, and you train it on your data. So what it does, it converts your texts, it puts your text into different buckets. So once trained, it's very fast. Well, hash is usually very, very fast algorithms. So both putting somewhere, retrieving, adding something is easy and cheap. So that's maybe a very good alternative approach to consider if you're thinking a project like that. Okay, the third article in this series, so the author recommends a particular company, Third AI, and they implement this approach, and even more than that, they implement it using commodity CPU-based computers, cloud computers, without GPU, because as you know, GPU-based computers are extremely expensive on the cloud. So again, maybe a valid approach. Okay, running embedding models. If you go on Hugging Face and you look at the leaderboard for embedding models. What is embedding model? It's a model which takes a piece of text and convert it into a vector. Or maybe it goes token by token and each token converts into a vector. So now you have a two-dimensional like tensor, right? And these are the models. There are about 100 of them, well, 79 now. And if you look at these models, BGE large, BGE base, GTE large, GTE based, E5 large, BGE small, instructor, whatever. And then you go, where is the big one? This one, 8,000, this is a sequence length, and text embedding ADA002. Well, this is OpenAI, right? So, and you see it creates very big vectors, 1,500 numbers in each vector, and it can accept a very long piece of text, which is usually not a good idea. Like when you're indexing, it's actually better to use smaller chunks. And I looked at the top and I made a table comparing what kind of GPU you will need to run these models, because all these models are networks. So they are doing encoding. This is like half of a transformer model. And so these are the requirements. So this one, BG large, has 12 billion parameters and requires about 40 gigabyte GPU, which is a big GPU, which is something like 8100, which is expensive. But the next one, which is BGE base, only 0.2 billion parameters. It requires only 4 gigabytes, so you can run it on your laptop. And if you look at the average quality, 63.98, 63.36, it's about the same accuracy. So, well, yeah, you can just use this smaller model and be very, very happy. Or this one also, it's GTE base, and it 0.14 billion parameters, only 6 gigabyte required, and also pretty good accuracy. Now this the upper one, the BGE base, was recently in August added to LangChain, and now you can just call it from LangChain, which is great, which makes it very convenient. But any of these models you can easily call. You just need to like import torch and like whatever, and write some Python code, and it will work. Okay. Next, about hardware. If you want to use your own hardware to run those models. So here's an example of a desktop which has 128 gigabytes of system memory and 24 gigabyte of video memory, which can run well, size not 70 billion parameters, but all smaller models it can easily run. And here's example. It's $1,700. It's refurbished on eBay, and there are multiple. So anywhere between 2K and 3K in dollars, you can get it. So great. You can run good quality models locally on not expensive hardware. You don't need server type computers. Like a nice gaming computer is even better, right? You also can use hosting. Amazon hosting is extremely expensive. Google hosting is better, but there are some other companies, like for example, Lambda Labs is known to provide good prices. So they're on demand on a decent computer with 48 gigabyte of VRAM. So this is a lot of video RAM. It's only 80 cents per hour, which translates to about 570 per month, which is possible. But if you make a 1-year commitment, you can maybe half the price, and then for a year you pay maybe 3,600. And then there are some other cheaper, like for example, runpod.io, their price, on-demand price, is 44 cents per hour. So here it was 80 and now it's 44, so it's even cheaper. So you can check out these links. I will put everything on GitHub after the lecture. Some resources. So this is a good link about using PostgreSQL as a vector database. Oops, sorry. This is how to run Llama 2 on your local computer. I showed you some examples, but here there's a step-by-step tutorial and video. Here is a bunch of link about the project called Private GPT. So you see it's a GitHub and description and video. And here local GPT, which was inspired by Private GPT. And again, you have GitHub and a set of links. And this is how to run 7B model locally using CPU only, no GPU. This is a really good GitHub project. It compares quality of different models which you can run locally. And the best in his tests was Llama 2 13B chat. So you can follow this GitHub link and get everything and look. It's a really nice project. Building local agents and tools using Linux, GPU, and Llama 2 7B. You see how many projects are now using 7 billion parameters and 13 billion parameter models, because their quality is approaching the big models. And again, for your business needs, you don't need a really big model, because a really big model knows quantum mechanics and ancient history and can write poems. But for your business use, you just need the model which can understand the language and which can describe your data and give you a response in natural language. And small model can absolutely do it, especially with the progress in the training data set. Okay, and this is a link about how to run Llama 2 on Mac. And that's what I do. I can do it using Alama, which I showed you before, but also I can just follow this tutorial or something similar. There are a lot of tutorials. It's getting easier and easier and easier. Okay, this is it for today. I'm stopping the presentation, stopping recording.